Chapter 2, element of high quality program. Okay, now the first step in every program is normally declaring and using variable and constant here. So basically, in some of the programming language, before using the variable, you have to declare it. But in the Python, we do not need it. But it is really good practice for you that whenever you use variable before any program, you have to declare it here. So in the declare, you have to define what is variable name and what is data type. So data type it can be integer, can be a floating point, or can be in string, or can be character, whatever it is, right? So basically for every program, the first step is you have to declare and using variable and constant here. We mentioned about what is a constant and what's a variable later here. So the first step, you have to understanding the data type. Data type describes what value can be held in the item. So it might be integer, so integer number, everything is a real number, right? It's a whole number here, 1, 2, 3, and -10 or -5, right? And how item is stored in the memory. So it depends on the data type. It depends on data type. It depends on data type. How the item is stored in the memory is not the same. Think about, to make it simple, you can think about for integer number is stored in the 2 bytes. Right? Think about that. And for the floating number, it's stored in the 4 bytes in the memory. They are not the same. Right? And also, what operation can be performed on the item? You can think about for the number, you can add them, you can subtract them, you can divide them together, right? But for the string and for the character, you cannot. So it depends on data type, right? So basically, for every program, the first step, you have to declare the variable name and constant and the data type here. And all programming language support this data type. Numeric consists of numbers that can be used in math, and have string if anything is not used in math. You can think about string. Normally in every program, string you put it under the quote mark or under the double quote mark here. Right? So you think about hello here, hello world here. Okay, so basically in the pseudocode, it break it down in the 2 type data type. You have the number and have the string here. So when you define when you declare a variable in the pseudocode, use the num here. Right? So you think about num, you have you can think about cell tag here, right? Cell tags here, or you can have a string here. You can have string. You can assign it to the hello world, whatever it is. Right? So basically, in the pseudocode, you only care about num and string only. You do not have to go into a specific integer or floating point or whatever. Okay, now you have understanding about the unnamed literal constant here. You have the 2 types of constant. You have numeric constant or literal numeric constant that contains the number only, and number does not change. Remember, constant that always stay the same. Right? Constant always stay the same. You can think about in your program if you want to find out what is a cell tag here, right? So you can define the constant here. You can define the constant here. You have the state. State rate, right? And you can what? Oh, come on. Here. What's wrong with this one? Sorry about that. I cannot. Think about this one. It was 0.07 here. Right? So see, state rate here, it is a constant name, and 0.07 it's a rate of the state rate. And normally for constant, you have to declare at the beginning of the program. And normally for the good practice, you put everything in the uppercase. It's very, very helpful for user to follow up with your program here. Okay, and that is numeric constant, and also we have the string constant also. String constant, everything is string here. Right? Again, it's not changed during the whole program, and normally it have includes in the question mark here. It can be the single or double question mark. Now that is constant. Remember the constant is everything not changeable. I always stay the same during the whole program here. Now the second thing is a variable. Variable that means it varies. That is changeable, right? It's changeable. And about the variable here, also for every variable, it is the name, memory, location. Now think about when think about it's a program here. In the program, you have the length, you assign it to the 20 here. So actually, what happened here? It reserved one slot in the memory, and the name of the slot here. The name of the memory slot here is the length here, right? And it stores the value of 20 into the memory slot, right? So later on, you see later on when you have area, here, and you assign it to the length time width here. So what happened here? It take it out. It reference to the memory slot with the name and length, right? It take it out the value and assign here, 20 here. And again, you have one more memory slot in the width here, and it take it down number 10, it assign to the width here. So that is the way when you work with the variable. Remember that variable is always reserved one slot in the memory and reference to the name of the slot here. Right? And again, it is a variable that means it's changeable. Right? You can change it here. So one time you store number 20 here, the next time you can store it into the 40 and 50 or whatever it is. But remember, whenever you got a new number, it will override the old one here, right? Reference to the same slot, so that's why when you get the new one, it will override the old one. Okay, that's why the content can vary or differ over time. Declaration is statement that provides the variable data type. You have to define it is a number format or string format. Identifier is a variable name. And optional, you can have initial value. So think about in the program, you can declare here. You can declare. This one you have the num. It's a number format. It's a pseudocode number format. You have length here. And later on, you can assign length equal to 20 here. It's up to you. You can assign later or you can assign at the time you declare it. Right? Okay, so that when working the variable on the left here, it is a flow chart, and on the right it's a pseudocode here. So we see if you look in the flow chart also, you have the declaration here, right? You define for this one, you declare my number in the number format, my answer here is the number format, right? And now you got input from user, the number. So think about he entered number 10. Now user double it, you have number 40. Double it in number 40, and you take it out, we bring it out number 40 here. That is a program here. And you can do the same. This is when you work with pseudocode, you see, you have start and stop here, right? Declaration here, number format, variable name, number format, variable name, right? Input, processing, and output here. Okay. Okay, now we have the data type. You can have the numeric variable. It's a whole digit only, right? So can be the integer or floating point, whatever. And of course, when you have the number format, you can perform mathematical operation with this one. You have string variable. It can hold text only. You can think about letter alphabet here, right? And also you might have a special character. Okay, and now you have the definition about data type, right? You have the definition of identifier. Identifier actually is a variable name. That's all. It's a variable name here. And again, you see, it strongly recommend you that. You have to choose. You have to choose reasonable and descriptive name for variable. Now, instead of using X or Y, you use the length or use the width here. Okay, programming language have rule for creating identifier. Most language allow the letter and digit. Right? Some of the language allow the hyphen, and also you cannot use the keyword. Reserved keyword are not allowed. Think about in the pseudocode, you cannot use input for variable name, right? and you can use the output for variable name. Okay, and remember variable name are case sensitive. Right? So think about when one thing is that when you work with the Raptor, it's not really case sensitive. It's not care about. So we think about if you have variable name in the Raptor here, you have a price here and price here. Sorry, and price here. They work the same in the Raptor, but in the other in the mode of the programming language, they are case sensitive, right? So if you have the price here and you have another variable price here, they are not the same. And think about this one. If you work, sometimes you have the syntax error because of the inconsistent variable name here. Okay, so variable name, they are case sensitive. Variable name must be one word only, right? Must start with a letter and should have some appropriate meaning. That's the one I mentioned it again and again. Okay, why come back to this one? Okay, now see, you have the variable and naming convention. Basically, you have many conventions. You can have the camel casing a Pascal, casing a Hungarian notation. Right? You can use this one here, and of course, you do not have to follow it, but it's a good practice to follow with one of the convention here. Okay, now assigning value to variable, right? Assigning variable here. That is assignment statement here. So whenever you assign every statement, it's actually you have to work everything on the right first. Right? You have to work everything on the right. You have to figure it out. Right? So about this one, here's the process here. You have to reference to the slot memory. Is the name of my number here. My number. So think about we store the number 10. It take it down number 10. And it time it to 2, you have number 20. So you have to do everything on the right first. So after we figure out the value, you assign this value to the variable on the left here. So after the step, you have another slot in the memory, and the name is my answer here. And you store the number 20 into the variable name here. Okay. So that is the way you understand how it works with assignment. Remember, it's always execute everything on the right and assign that value into the variable name on the left here. Now you assign, you have to use the equal sign here. What is it? Okay, always operate, always execute from the right to the left. Okay, and sometimes you can initializing the variable when work with the declare the variable, right? So see, when you declare the number format here, your salary, and you assign the 14.55. Right? You can assign it, you can initialize the variable at the beginning, at the time you declare the variable name here, or you can assign it later on the program. It doesn't matter. Garbage is a variable unknown name, right? So variable must be declared before they are used in the program. So basically, from now on, if you work with a simple code, make sure that you have to declare variable before you work with your program. Now, constant again, constant. It is similar to variable. It has the name also. It has specific name. Can be assigned a value only once. It never changes. It always stays the same in the whole program here. And you should assign the its full name to the values that will never be changed during the program execution here. And they have the definition of the magic number. The magic number is an unnamed constant here. You can think about this one here. You can think about, you find out what is the tag amount, right? A tag amount. So we have the price of item, you time with the 0.06. So this one you can guess, right? This one program you can guess that 0.06 here. It is self-tag here. But again, if you have a huge new program, very hard for you to follow up with the 0.06 here, right? So it should be better at the beginning of the program here. You have to declare the constant name. Remember that normally they put it everything in the uppercase at the beginning of program. So see, instead of that, I define the sales tax amount equal to 0.06 at the beginning of the program, and later on I can use it variable. Constant name here. It's very helpful for the user to follow up what's going on with the program. Now perform the arithmetic operation. So we have some of the standard arithmetic operator. You have the plus, add them together. You have subtraction here. You have asterisk, that's the multiplication, and you have the division also. Okay, and you have the rule of the precedence, or whatever. I normally call the rule of priority. So also call the order of operation here, right? So it dictates the order in which operation in the same statement are carried out. And so basically, if they have the same priority, you work everything from the left to the right. I should think about this one. If you have to find out the value of the whole problem here, what do you think? What is the value of this one? What is the value of this one? Try to find out. You can try to find out what is the value of this operation. So basically, you have to understand about the rule of the precedence over here, right? Everything inside the parentheses, you have the higher priority. You have the high priority here, right? And later on, you have to work the exponent. This one is the exponent here. This one double sides opponent. And later on, you have the division and multiplication. And last one, you have the subtraction and addition. Right? So good thing about this one. What is the value? What is the outcome of this operation? Can you tell me? If you look on this one, what is the outcome of this operation? Try and tell me what is the outcome of operation. Three. Okay, can try here. Now, the first thing, you have to work everything in parentheses first, right? This one here, you have to find it out 4. Sorry. So you have 4 here, right? Now in parentheses, everything here. You have 10 minus 2 times 4, right? Now inside the parentheses, you have to do everything with the multiplication first, right? So that's why you have 8 here. You have 10 minus 8. So see, for this one you have 2 here, right? So I can rewrite here. 15 minus 9 over 3 plus 3 exponent number 2 here, right? Okay. Now see, again, you have to do everything with the opponent first next year. So that's why you have 9 here. Right? You have 9 for this one. Make sense? 3 raised to power of 2, you have 9 here, right? So now we have 15 minus 9 over 3 plus 9 here. So what is the outcome here? You see, you have 15 minus 3, you have 12, plus 9, you have 21. Right? So for this one, in the output, you have a 21 for this one. Okay?
Why wouldn't you do division first?
Division here? Yeah, division here, 3 here. That's why you have 3 here. Right? That's why you have 3 here. Okay, so that you have to understand about the process here, about the variety of the operator here. So everything inside the parentheses you have to do first. Next you move to the exponent. Next you move to the division and division. And the last one you work with subtraction and addition. And then if you have the same variety, you do everything from the left to the right. Make sense? Any question? Okay. So see, you have the rule of the priority here. You have to do everything assignment for allow it. Sorry, it's allow it here. You have addition, subtraction, multiplication, and division. And I don't know, this one is missing. It might be the exponent also, and parentheses also. Now the integer data type, dividing an integer by another integer is okay. Dividing what? Dividing the two integers result in integer and any fraction part of the result loss. Okay, now see. So think about if you work with the Python here. Think about if you work with the Python. In the case, right? In the case, you work with the Python. So in the division, you have many. In the Python, you have some of the form here is 10 divided by 3. You have a floating point for this one. But if you want to take it out the integer part, you see 10 divided by 3. You have number 2 here. You keep only about the integer part, because that is some of the example when you divide 3 integer and you keep the integer number only. You can use that one. And you have modular also. Modular is that remainder operator. Tell me what is the remainder after the division. I think about the case here. In the case of the Python, when you work with the division, you think about 25 and modular for the number 10. What do you think? What do we have here? Remainder. What is it? What's the remainder from the 24 divided by 10? 4, right? You have the 4 remainder here, right? Okay, so in the case you work with the Python and you want to find out what the remainder, you can use this symbol here. Okay, now understanding the modularization is very important concept. Very important concept in the case you work with the program here. So first, you have to understand what the module. Module is a subunit of program. So think about you have a huge program, right? Huge program, you can break it down into multiple modules. You can break it down in multiple modules here, and they can also call the subroutine or procedure or function or method here. Now, to call a module, it uses name to invoke the module and cause it to execute. Now, the process of the break it down into multiple modules, they call it the modularization. Modularization is the process. You break the huge program into the multiple submodules or multiple modules here. Okay, so basically in every program, you have the main program. It is a basic step. It's the main body of the program. It's the main body of the program, right? So in the main program, normally you include the module header, you have the module body, and you have the module return statement. I think about you have the header, you have body that where you execute every operation, and now after you do everything's operation, you return what you have here, right? Okay, and how you name the module? It's similar when you name the variable. It's quite similar. It's a name. Understand the syntax when you use a variable name here. And module name are followed by the set of the parentheses here. So how it works is a modularizing program here. You can think about this one. You can think about install program here. You can think about install program here. You can think about install program. You have the think about this one. You have the main program here. For every program, it's starting from main program, or it's the main body of program. So in the main program, you can call it to any module. When you break it down into multiple modules, you can call to any module. So whenever you call the module, what exactly happened here? So whenever in the main program you call the module, the program is stopped from the main program. It jumps to the module you call here. It jumps into the module call. It executes every statement from the first one to the last one of the module. So when you come to the every last one of the module, it jumps back it jump it back to the main module and it move to the next statement in the main module. Okay, that is a key concept you understand about the module here. Remember that whenever you call the module, the program jump it to the module, execute everything from the first statement to the last statement, and when you're done with the last statement, you come it back to the main program and you move to the next statement in the main program. Okay. Now, in the flowchart here, so how we work with the modularization in the program here, the symbol used to call module is a rectangle with a bar across the top. So when you see a bar across the top, it is a module, right? And place the name of the module you are calling inside the rectangle and draw each module separately with its own sentinel symbol here. Now think about this one. You can think about this one have no module. You have everything. It's a declaration, right? You have the input, output, and output here. That is very simple program. It's very simple program. You do not have the module for this one. But for this one here, you see, when you can group them together here, right? You see, you have the declaration, you have the input here. Now, you see in the flowchart here. When you see in flowchart, you have the rectangle and a bar here. It's a bar for this one. It's a module. It's a module. So what happened here? When you execute the module, it jumps it to the module. Actually, you have to define the module here, right? You have to define the module. It works here. Now, I'll put this one, return here. When you return, you come back to the main module. You move to the next statement here. All right, so see, basically this program here. Basically this program, if you look on this program and, if you look on this program and this program, they do the same, right? But the only thing is that you group some of them together here. You group some of them together for this one. You group some of them together. You put it into module name address here, right? That's all. That's the way you work with the modularization. You group some of them together and you break it down in the module. This is very simple program, so you do not see benefit of the module. But you can think about it's a huge program. You can break it down into multiple modules, and each of them they have specific purpose. And you can assign one team for the module 1, you can assign the other one to the module 2, and so on. And they can do parallel together. And you can break it down into smaller modules. It's very helpful for you to verify and to when you want to debug what's wrong with the program. Now the benefits. So why you have to break it down in the module here? Benefits. It's easier to read. The first thing you want to break it down very complicated program into smaller one. So when you debug it, you see for each of the specific module, it's very easy for you to read it here. Easier for you to design codes and test program one module at a time. You see, break it down one at a time. You have different program module can be designed and code by different programmer. You can break it down in the work or labor division, right? Labor division here. And you can a single module can be used one or more time, one place in the program. That also is a huge benefit of module. You just define it one time, but later on, when we want to use it, you just call it again and again and again. That also. The module that perform common programming tasks can be used in more than one program. So we see it not only used in your program, but you can embed it in another program and you call it in the another program also. Later on, when we work with the real programming language, you can see that's one. Why? Now, let me come back with this example here. You can see with this example here. Where my mouse? Now I come back with this one. Very simple one here, right? So I think about this. This is very simple program. So basically, you will not see any benefit when you break it down in module. But anyway, it's a good for me to show you how you break it down in the submodule here, right? So think about this one here. You can think about this program. You can think about this program. I want to break it down into 3 submodules. The first module here, it is a input data here. I put its name is input data, right? And this one I do everything with the name is processing. And this one I do with the module output data here. I put data here. So now, in order to do it in the wrapper, we can do it. You see, you have the option of the code here. You have the option of the code. That is when you call the function. Sorry, when you call the module here, right? So for this one here, you can first step. I want to call the module name. It's the input data here. So I put input data. So we see when we wish to create the tab, the name here. Yes, I see. Now from the main program, I have one more module here. Its name is input data, right? And now I want to move everything in the input processing here. I cut it. I move it here. I put it under the input data here. Right? So now what happened here? I run program. So see, when I run program, it runs from the main program, right? So now it runs from start. It goes to the input data. What happened here? It calls the module input data. So it jumps to the input data. It takes it out, asks user enter the X and enter the Y here. Right? So after that, it comes back to the processing and the output here. Right? So now we can verify it here. You can verify how we run it here. See, you can run step by step here. I starting from main program. Start, go to the input data. See, whenever you call the module, it jumps into the module. See, it jumps into the module. Right? It jumps into the module. Now execute everything from the first statement to the last statement of the module here. You see. Now I have input X. I have number 10. Input length. I have number 20. Now see, it goes to the end of the module. Remember, when you go to the end of the module, you commit back to the main module. It moves to the next statement here, right? So now you see, I have error here, 200 here. Now I have output here, 200 here, right? Okay, you can do the same. You can do the same with this one. You can do the same with the program. Right? You can create one more module here. You can put the name in the processing. Yes, and you move this one to processing. Now you want to do one more module. It is the output data here. Now I move this one to the output data. Okay, so now you see. Again, this is quite a simple program, right? So we do not see much benefit when you break it down module. But at least you see program, you need input, you need processing and output here, right? And again, if you want to see what is the input, you can see that is the module input here. You got the data from user. What is it do? What is working with the processing? You see, it ties them up together, right? And what is the output here? See, user print it out. What's the error here, right? But this is a very simple program, but later on when you work with the final project and work with the final exam, you see you have quite a huge program. That's why it's very helpful for you to understand the logic of the modularization, to break it down into multiple modules here. Do you have any question with this one? Guys, do you have any question? Okay. Okay, so you see you have the sum of benefits when you work with the modularization here, right? Modularization here. Easier to read, easier to design code and test program. Different program and module can be designed or code by different programmer. A single can be used use one more time. Think about this one here. About this program, right? How can I work it another example? Now think about this one. Now think about the program here, right? So see, I just need to define it one time. I just need to define it one time only. But later on here, later on, I can use it again. Right? So later on, I can use it again here. Right? I can use this again, and this time I just do it. I just want to say not really. Okay. Now, anyway, let me do it here. So think about I define the input module for one time only, right? So this time I enter the number 10 here. I have number 20 here, and so see. And so see, you have the output here, it's a 200 here, right? So now you're asking me again enter the width and the y. That's where when I call another, when I call the input and one more time. So this is not really make sense with the example, but you know the logic here. You define it one time, right? You code it one time, but later on you can code it for multiple times, whatever you want. Now, to declare the variable and constant within the module. So basically, in the sum of the program, right, you have the local variable, so local variable and global variable. So the local variable in the current local variable, it is only variable and constant declared in the module are usable within the module. You only able to use it within the module. You cannot use it outside of the module. Now think about this one. If you think about this, you can think about this example here, right? In the Python. Okay, now this is a program. I break it down into the function here, right? So we have the main function here. I display that what happened with this one. This is what here. If you look on this program, what happened here? So what happened with this program here? You can see this one. Now, what happened with this one here? Every program is run with the main program, right? So see, the first step when we execute program, it works with the main function here. Now, it's a main, it calls out the main module. What is it? In the main module, again, it calls for the function display here. So what happened? When you call the display, it jumps into this function, jump function here. You got X, you got it. If I think about it, you have X here, number 10, right? Now you print X, you have print out number 10 here. So you see, again, in the main program here, you have X equals to X plus 10. You expect here 20. You expect here 20. But actually, you got the syntax error for this one. Because X here, it is a local variable. And it's only the scope of the local variable is only incised into the function only, the this model. Right? So basically, when you work with this one, you will got the syntax error. So that is the case of the local variable. Local variable is the one that only do everything inside your module or inside of my function. Right? So see, when you can run this one here, when you run this program. So I have number 10 here. So see, I have number 10 here, but see, in the program, unbound local error here, because when you jump to another function, it do not understand what's that here. Now, in that case, sometimes you have to work with global variable. Global variable, it is a global variable and constant. It is declared at the programming level. It's not inside any module. It's a programming level. So normally you have to declare and define at the beginning of every program, outside of every module, outside of every function here. So we have to declare at the programming level and visible and usable all modules combine the program and many programming. Normally many programming avoid the global variable to minimize error because sometimes we use it again and again, very confusing. Okay, now think about this one here in the flow chart here. That's the case. You work with the global, constant and global variable here. You declare at the beginning, and you see you have line number 1, line number 2, and line number 3, and you assign with the address here. Now what is it? Okay, now understanding the most common configuration for the mainline logic. The mainline logic is almost every procedural computer program follows the general structure. So later on we learn that we have 2 types of programming. The first one is procedural. That means you define the function and you call the function one by one. You passing the value into the parameter. And the other one is the object-oriented program. So in the object-oriented program, it encapsulates everything in the function and parameter in the one object here. Now we talk about the procedural computer program. It follows the general structure here. You have to declare the global variable and constant at the beginning. Remember that you declare the global variable and constant at the beginning, outside of any module, outside any function here. Right? Now you have the housekeeping task step you must perform at the beginning of a program to get ready for the rest program. And you have detailed loop task to do the core work of the program. And you see, after done everything, you have end of job task step you to take the end of the program to finish application. So everything here is a definition. It should be better. I can give you the example later to understand here. But normally you see, you have to follow the logic here. You have to declare everything global, variable, and constant at the beginning of the program before any function or any module. And you have the housekeeping, you have detail loop, and you have end of job task here. I believe I have some examples here. Now that is a most common of mainline logic here. I see that is step here. The first step, you declare everything about the global variable and constant. Now we have housekeeping. Housekeeping is a module for you to ready for the program. Ready program. After the housekeeping, you do the loop. You do it again and again for multiple times. And after you're done with the loop, you have to process the end of the job here. That is the end of the program. Now think about this one. Here. You want to do with the program, right? To take it out and the gross income, right? You figure out what's the deduction and what is the net income for every single employee in your company, right? So basically, when you work with this kind of program, you have to work with the loop. The loop, what is the loop? Loop is the kind of repetition action, right? Repetitive action. You do the same for the first employee, you do the second one, you do the third one, the fourth one, do it again and again and again until the last of the report here, until the last employee here, right? That normally is the process here. So basically, how it works is a program here in the mainline logic. You see that at the beginning here, you declare everything about the global variable and constant here. I see you need to define the name here in string format. Name is the name of employee. And here's the gross. It's the gross income, right? You have num deduct here. It's a deduct how much it can got deduct here. Net income. You see now. You see what's this one here? This one is a constant. This one is constant rate. Always stay at 25%. Now quit here. Quit. I will explain it later. Quit is again. It is a constant. It acts. That means keep doing it until you enter the employee with the name of and This one also, that is only the pre-now, pre-don't report and column heading and report also, right? You have string and line is end of report here. So now what happened with the program here? You see, first step, do everything with declaration. The second step, do the housekeeping here. So what's the housekeeping? You see, what's the housekeeping here? Housekeeping, it is step you have to do before the loop, outside the loop, and just before the loop. House step is the one you get ready to run for the loop here. So what's the housekeeping here? See, it print it out, right? Report heading, that means print out by don't report here. Output here, column heading, it print it out for the name. But the most important thing here, you input the name. So that is the most important name. So only you get the name. Only you get the name, you can run for the loop, right? Because the loop, whenever you run the loop, you only have the condition to check. You only have the condition to check. If yes, you exit the loop. If no, you keep doing the loop. Think about that one. Now see, the first step, housekeeping here, you get the name. So what's the name? When you got the name, you go to the loop here. I see. If name not equal to quit, what's the quit? That is constant. So see, you keep doing it and to the name David or Adam, whatever, keep doing it for the first one, the second one, the third one, the fourth one, and so on. And if you want to exit program, you enter you exit program. You see, if you do not have the step here, you have no way to check the connection with the loop here. You got the syntax error for this one. That's why the housekeeping is very important step. It happens before the loop, outside the loop, just before the loop, right? And all of the purpose is that get ready for you to run the loop. Make sense? Okay, later on I'll give you the example here. Here, this is the example here. Now, for now, I just want to follow the step here. So see, when you go to the loop, here, the first step, whenever you go to the loop, you have to check the condition first. If the condition is true, keep doing it again for the first one, the second one, third one, and so on. If not, you exit program. I see. For each of the time the loop executes, they call it iteration. That means what every time you do it one time here, right? So detail loop here. What's the detail loop? Detail loop, you get the gross of the employee. You figure out what is the deduct. You figure out what's the net here. Figure out what's the net here. Now you print it out. Name, gross, deduct, and net here. Now, the last step is very important here. If you want to move on to the next employee, you have to get the input name here. Otherwise, you can go with indefinite loop. Sorry. Let me explain it again. You see, if you look on the flow chart, and you can see you convert it into the pseudo chart here. Sorry, pseudo code here. They work exactly the same. You see, if you work here, and I expect that when you look on the slide here, you have to understand structure in the flowchart, and you have to understand structure in the pseudocode here. It's very helpful for you when you work with the debugging exercise. Debugging exercise that you to make sure you have to understand about the flowchart and pseudocode here, right? So now see for this one here. If you look on the pseudocode here, you see you have start and stop a program here. Stop and stop here. Start and stop here. That is main program. Now, in that one, you have everything here, declaration. You have everything here, declaration. Now, you have module name, housekeeping. What happened here? In the program, when you call the housekeeping, stop from here. Stop from here. It jump it to the housekeeping. It take it out, print it out. Get the name. That is very important. Now see, when you get the name, you return. You come back to the main program. You move to the next statement here. You check the name. It equal to the act or not. Keep doing it. Right? If not, keep doing it. What is it? Detail loop here. Keep doing it. What is in the detail loop? Again, it jump with the detail loop. Right? You enter the gross, enter the gross. So you got the gross. You figure out the deduct net. I print it out. If you want to move to the next employee, you need to get the new name. Right? You get the new name. So now you can see very straightforward in the wrapper here. I do exactly the same. I just convert everything here from the pseudocode and flowchart. I convert it into the wrapper here. So if you look on the wrapper here, if you look on the wrapper program, sorry. Yeah. If you look on this interrupter program, you see that is the first step, right? So basically, in the interrupter program, you do not have to declare the variable before you use. That's why I skip this one. But this one, I have to put everything in the constant here, right? Constant here, right? 25%, which I here, right? And the output here, payroll report, and the name gross here, and apply and report here. Now, that everything here is declaration. Huh? That everything here is declaration. Now, I run program, I go to the housekeeping. What is the housekeeping here? See, housekeeping is that when I print it out, the most important thing I get the name. The most important thing here, I get the name, right? Because I need to get the name in order to check the condition of the loop. Otherwise, I got the syntax, right? So see, when I got the name, I come back to my program, right? To check here the condition here. Check the condition here. Check the condition. If the name equal to I exit the loop. If not, I go with detail loop. What's the detail loop here? Detail loop, you see, you figure out the gross. You figure out the you got the gross. You figure out what is the deduct. You figure out what's the net. You print it out. Now, if you want to move to the second employee, the third employee, the fourth employee, or next employee, you need to get a new name. You get the new name. Otherwise, later on explain that you have indefinite loop here. So at the result, to print it out here. Right? So see, that is the process. I convert everything from the pseudocode to the router here. Exactly the same. Exactly the same. You can see here. You can see in the slide here. You can compare it here, right? You can compare it. I can convert everything here. Sorry. Yeah, this one. I can convert everything exactly the same. And you can see this one declaration. I put it here, everything here. Or I can do it one more thing. I think it should be better here. I do it in declaration. And I move everything here. Sorry, I move everything here under declaration. Okay, so see the first step declaration. Housekeeping, get the name. After the get the name, I check it equal to quit here. It's quit is right? So if not, keep doing it. So the first employee, the second one, the third one, the fourth one, and so on. Now, see how it works here. How it works this program here. You can see you can follow up here. So when I run it here, right? So first step, right? See in the first. Okay, that's the first step here. Enter the name item. Item here. What happened when you have the name item? It goes to the loop. You check name item is not quit. Quit that means right? It's not. That means you go to detail loop here, right? So you go to detail loop here. Now I enter the 1000 here. So what happened here? We go to enter 1000 here. I figured out everything in the detail loop here. Deduct, net, print it out. Now, if I want to move to the next employee, I need to get a new name. I get a new name here. That's why I have to enter the new name. Or if I want to exit, I put the exit. Make sense? Now, see, if I put I exit program. Okay, that's all. Only I have one employee here. Let's do it one time only. But of course, if I have 2 or more, I can do it again and again. Now, the thing here, for this program, I just want to go back to see for the housekeeping here. It's very important for that. If housekeeping is an initial step before the loop, outside the loop, and to make it ready for the loop here. Now, what happened here? What happened if I delete this one here? You see, I got the syntax error here. See, if I run here, if I run it, see, it tells you the name, variable name. See, variable name is not found. Because here When you run with the name here, you check name equal to quit or not, but you have no idea what's the name. Right? Actually, so this one you need to get it in the housekeeping here in order to run with the loop. Make sense or not? Okay, that's why. That's why here. That's why I had to come back here. I have to put it, get in there again. Now, the second step here, you see, when you go to the, hello?
Yeah, so excuse me, I don't understand the word of loop on the main section.
Is that we will go into detail loop later. But now, for now, you just understand that loop is that the action you do it again and again and again. And now remember that for a loop, in order to do the loop, you only have the condition to check. And the output of the condition is only true or false. It's only true or false or 0 or 1. So if the condition here, because in the router here, if the condition is no, you keep doing it, you keep doing it, you keep doing it here. Now, let me explain it again. Think about I have the 3 employees. I have the 3 employees here, right? To make it simple, I have the 3 employees. I have the employee A, and his gross income 1,000 here. And I have employee B, it's in 1,500 here. And I have employee C, I have 2,000 here. Right? So now, what happened here? In the housekeeping, for the first step, I need to get the name of A. Enter the name, I enter the A. So what happened here? It run, it check the condition. What's the name? Name A. Name A equal to quit or not? Quit, I put it is a quit, I put it is a here, right? So see, it's not this one here, not equal to x. So it's not equal. I go to detail loop. What's the detail loop? Detail loop, that means I have to find it out. I have to figure out. I have to figure it out here. In the detail loop here, I have to figure out what is the gross. Sorry, I need to get the gross. I have to enter 1,000 here, right? And I have to find out what the deduct. Sorry, what's the deduct? What's the net here? And print it out. What the deduct? What net? And now, see, that is a one iteration of the loop. I done with one iteration loop, right? Now, what happened here? If I want to move on with the second employee B, I have to enter name here. I have to enter the name B here, right? So what happened? When I enter the name B, it go back to the loop. You see, when it go back to the loop here, when it go back to the loop, it check again. Now B is not equal. I can do it again with the second one. Now we move to the C. C not equal to I can do it again with the third one. Now you only have the 3 employees, and if you want to exit, so the last step here, the last step, user enter here. User enter the last step here. User enter it. X here to exit the loop. Now I can run it again step by step. You can see how it works with this one. How it works with this one here. Now run step by step here. See that and everything here. Now housekeeping. See housekeeping. Most important concept here in the housekeeping. I get the name. That is totally necessary in order to run the loop, right? So I put it here. I put it I here. Now see, when you work with the A, I have name I here, right? And see, I have quit I here. They are not the same. They are not the same here. So what happened here? It go to the main program. It check it not equal. You go to the data loop, right? Data loop here. What happened to the data loop? Jump to the data loop. What is the gross? I enter here. I enter this guy 1,000 here. I want this guy 1,000 here. Alright. So we see it find out. Deduct here. You see the find out here. Deduct is 250 here, right? Now what's the net here? Net here is 750, right? And print it out. You see, I print it out here. This guy 1,000 here. Deduct 250 and net 750. I'm done with the guy A. I done with guy A here. Now, what happened here? If I want to move to guy B, I have to enter the name of the guy B here. I move here. I put the name of B. I will see what happened here. Now name B. Quit here. Not the same again. Not the same again. So again, it moved to the second iteration. Now this guy 1,500 here. 1500 here, right? Now, figure out what it is, he got here. He got this one, next here, right? Now, if I want to move to this guy C, I have to enter C here, right? I have to enter the name C here. Now, C here. This guy, 2000. Now see, this guy, see here, right? Now, see, the next step here. Tell you, enter name or enter I. So what? Think about I only have the 3 employees, right? Now I want to stop it. I am the one who control it. I am the one who make the decision if I want to terminate it or not, right? So now I put I here. See, right now name is C, right? But now what I put I here, what happened here? See, name I, quick I, they are the same, right? They are the same here. So when is the same, we go to the loop, check the condition of the loop here. They are the same. I. Yes. Out of the loop. Right? Out of the loop here. See, out of the loop here. And I exit my program. That's all. Make sense?
Yes, that's great. Thank you.
Okay, now something I want you to keep in mind that again, because I teach it class many times already. I see that you have to understand the logic here. The housekeeping, remember, only before the loop, outside the loop, right? Just before the loop and outside the loop. That's the thing. And it really need you. It really help you to get that in order to run the loop here. If you're missing anything with the housekeeping, you have no way to check the condition of the loop, and you cannot run the loop here, right? That's the first thing. Now the second thing here, in the loop here, at the end of the loop, you always have to change. You only have the action to change the variable who controls the loop. So think this one here, in this example here, the variable name is the one who controls the loop. Who controls if you want to run the loop or you want to exit the loop, right? So think about this one. If you enter A, do the loop. You enter the B, do the loop. If you enter C, do the loop. But if you enter X, you exit the loop, right? So the variable name here is the one who controls how to exit the loop. And if you work with the loop here inside the body of the loop, at the end, you only have action to change the variable here. Otherwise, it will go to indefinite loop. Now, let me show you how it works here. Now, let me show you how it works here. I think about this one. I go to the data loop. I delete this one here. So what happened here? Now, see what happened here. If I run this one here, right? If I run this one here, housekeeping, I have the name A here, right? I have name A here. So see, I do with the guy A 1000 here, right? I do guy A 1000 here. I figured out his net here is 1700 here. So what happened here? What happened here? I move to the second iteration. What's the name? Name is stays the same A here. See, you have no action to change the name, right? The name is only A. That's why it runs it again forever. And you have no way to exit the loop. Make sense? Right? That's why in the body of the loop, you only have action to change the value of the variable who controls the loop here. Make sense? Okay. Do you have any question? You see, I do it again here, right? I do it again. It's the same with guy A. Now, if I enter the cross again, 2000 here. It stays the same with the guy named A, right? And we do it again. Now, do it again. See, here it's always staying with the name A. That's why I have no way to exit program. And this guy, they call it the indefinite loop. Run it again forever. Right? Okay. So I think you should take a short break for 5 minutes and we come back. So we see in this program again, I break it down into modular structure, right? Break it down declaration or between the detail loop and end of job. Okay, that is the mainline logic. You should understand everything about housekeeping and body of the loop and end of job here. Now, that is the you work with with Raptor, right? When you work the Python, follow the same logic here. So if you look at this program here, I work with the Python. So I do exactly the same, right? The process is the same. Everything here is declaration, right? I see they are constant. They are constant, global constant. I put it everything at the beginning of the program and outside of every function here. Actually, for this one, I do have function, right? So see, in the housekeeping here, right? The more important thing is that I got the name. So actually, that you can think about this. The name here in the housekeeping is the name of the first employee. I only need it for the first employee. Now, so when I got the first employee, I go to the loop here. I go to the check if the name is not equal to the I keep doing it. Let's see. When I got the name, now if I want to move on to the second or the third or the fourth employee, again, I need to get the name here, new name here, right? Makes sense? Now see, it works exactly the same. It works exactly the same, right? So think about I added I here, and the gross here 1,000 here. You now can write it down. This is A, and net income here, right? So now see, I have step here. And there's a new name, right? Otherwise, it is that indefinite loop, right? So I think I have B here. B here, I have a 1,500 here. Now I have the C and 2,000 here. Now, if I want to exit it, I put act here. So when I put act, come back to the main body. Check now name equal to exit loop. That's all. That's all here. Now you see now what happened here. Again, you can see what happened here. If I delete the housekeeping here, I got a huge problem. I got a huge problem with this one. See, not understand. What's the name? No idea. That's why you need this step here in order to get that in the loop and before the loop. Makes sense? Okay. Now, that's the first thing. Now, the second thing is that you can see for this one. If I delete this step here, okay, it will be indefinite loop, right? Indefinite loop here. See, I run it again here. Now, 1,000 here. Okay, and the gross never ever change name, right? And the gross 1,500 here, 2,000 here. I don't know how to exit program. I have no way. Okay, that's the thing you have to understand about the logic of the mainline logic here. Sorry. Mainline logic here. Okay, so now I just you to understand the idea of the mainline logic, and you can see again in the left it is a flowchart on the right. It's a pseudocode. You have step of declaration, and you have the housekeeping. You have the main body loop here. Housekeeping. You have the main body loop, and you have you have end of job here. And in the pseudocode, you have to pay attention that you have a y and ny. They are loop that keep doing it until the condition is not correct. And do the same as this one here. So basically, if you understand the logic of the mainline logic here, you can do it with the debugging inside. You can do exactly the same. So let me try to open one of the debugging exercise here. Let's see what happens. This one have no loop here. That's one very simple, but I think it was. Okay, now see. This one follow exactly the same rule here, right? This one here, you have declaration, you have the housekeeping, right? You have the loop here, you have the loop here, right? And you have end of the loop here and end of the job here. So now see, in this program here, the purpose, the first thing again, I strongly recommend that you have to read in the header comment here, right? What is the purpose? This pseudocode segment is intended to compute and display the average grade of the 3 tests for any number of student program execute until user enter negative value for the first test score. Right? So how it works here? You can think about this one here. You can think about this one here, right? You have the program here. You have A. You might enter the 50 and 60 and 70 here, right? So we have to find out what's the average here. 60, right? Now we move to the B. You have the 60, you have the 70, and you have 80. You find out 70 here. Now, if you want to terminate it, if you want to exit program, you have to go to the C, and you have to go to the next student, and you have to enter the negative number. I think about you enter the negative number 10. You will execute. Sorry, you will exit program. Right? So now, if you look on this program here, you have to tell me some of the specific questions here. What is the variable who control the loop? What is the variable who control the loop here? What is the variable who control to continue or to exit the loop?
This one.
Test number 1, right? That's the test number 1. You see, here, if the test number 1 greater than 0 or not, keep doing it. Right? Keep doing it. So test number 1 here, it can be for the first student, can be the second, can be third, and so on here. Right? That's the first step. Now, see, if you have the condition to check the test number 1 here greater than 0 in the main body of the loop, you need to get the test number 1 of the first student in the housekeeping. Right? It's a housekeeping here. That's why you see you have the housekeeping here. The process of the housekeeping here is that you need to get step number 1 of the first student only needs of the first student, right? So think about if you enter the number 50 here, and if you check 50 here, if not, it's greater than, right? It's correct. Keep doing it. The main loop. Main loop, what is it? You need to get the test number 2. You need to get the test number 3. You find out average, right? Now, when you find out the average, what is the next step?
Answer test number 1 again.
Yes, right. I see the process here. You need to get the test number 1 again, but test number 1 here, it is the test number 1 of next student. Right? It's next student here. Make sense? So see, if you understand the logic, it's this one here. If you understand the logic, it's this one. It follows exactly the same. Huh? So now I expect that you have understand the logic of the flowchart and the pseudocode, and you can apply this one into the debugging exercise. It follows exactly the same rule. Okay? Okay. So basically, in the planning process, when you work with the program and you want to break it down into a modular structure, you have to break it down in a module into multiple modules. You can work with a hierarchy chart. Hierarchy chart is shows the overall picture how the module as they are related together. They are related together and tell you which module exists within the program and which module calls the other one here. I think about this one. This program here, I break it down. Main program, we break it down in 3 modules here. That's housekeeping and detail loop and the end of job here. Right? So it's very straightforward to know. You understand that this program, we break it down in the 3 modules: housekeeping, detail loop, and end of job here. And again, in some program, it's too complicated. You can break it down furthermore. Right? You can break it down furthermore for this one here. Housekeeping, you break it down into get order, or in the detail loop, you can have the process order or get order, and even in the process order, you can break it down furthermore. But you see, when you work with the flowchart here, you can see how they are related together and what is the relation here, right? What's the relation here? Now, a feature of the good programming design, right? Use programming commands where appropriate. The command, what is it? The command is really helpful for you if you are the programmer. if you are a coder, but it has no benefit to the computer point of view, right? Because when computer runs an execute program, it will ignore every command. It has no care. It doesn't care about the command here. But you can think of if you have very complicated program, it's very helpful for you to see what is going on by reading the comment here, right? So think about if you look on this one here. If you look on this one, you see the comment here. It tells you that now I starting with the housekeeping here, and I need to get input ready for the loop. I know, I get the name. Now I tell that is the main body of the loop here. Tell that main body of the loop, and this one tell me it's the end of the job. Right? Again, this one is very simple program. You do not see much benefits. But again, if you have very complicated program, you have a huge benefit with the comments. Now, that's the first step. Use a programming command where appropriate. And the second step, the identifier should be chosen carefully. Identifier, that means it's a variable name or constant name here. Try to make it meaningful here. So instead of using X and Y, you use a length or width or whatever here. And try to design a clear statement within your program and module. Always make it a clear statement here. Write clear prompt and echo input. I explain what the echo input later in this program. But remember that always try to include the prompt in your program. Prompt from input and prompt for the output and stuff, right? And continue to maintain good programming habits as you develop the programming skill. So always stick to some of the very basic steps or the good programming practice here. Okay, now program comment. It's written explanation of programming statement. It is no part of the program logic. So basically, again, from the computer point of view, they have no benefit. When we execute program, we ignore everything about the comment here, and it serves as internal documentation for the program. It serves it for you if you are the programmer here, right? And so syntax is different among the programming language. You have many type of programming language, and not of them they follow the same syntax. So you have to know about the specific programming and specific syntax when you work with the programming here. Flowchart, you use an annotation symbol to hold information that expand what is stored within the another flowchart symbol here. Now, so normally, basically in the pseudocode and in many programs, whenever you want to do with the comment, you can use a double slash here. That is when you work with the comment. Yeah, with the double slash here. Okay, I think about this one here, right? So for this one, here you have the command for this one also. Very straightforward, right? So you see, enter the number of hours. Now rate is expected to increase in the January 1st. So program assume that all employee makes the same standard hour rate. It's very helpful for the programmer here, right? Now choosing the identifier or variable name, give a variable or constant name that is nouns. Give a module identifier that is a verb. So when you work with module, you put the verb here because you call it, you do some action here, right? So it's a get input, print out the output, and do the processing, right? And use a meaningful name. That one I mentioned it many times here. Use the pronouns simple name. Okay, very careful about the abbreviation here and avoid digit in the name. Avoid. Use a system language allows separate word, multi-word, a variable name, include the form of the verb to be, name constant. You see, whenever we work with the name constant, use uppercase, right? It's very helpful for someone to follow up your coding here. Okay, now designing a clear statement, avoid confusing the line break and use a temporary variable to clarify the long statement here. Now, example for this one. Why? I think I should have some here. See, for this one here, right? Using the temporary variable to clarify the long statement here. I'm thinking about this one here. You want to find out the sale commission, right? The sale commission, sale commission is from you can figure it out from the discount rate, right? And time it the original price, and you minus it from the original price. Right? So basically, you can find the sales commission from the formula here, right? But sometimes you can use a temporary variable to make it to clarify the long statement. You think about this one here. So instead of this one here, sorry, time with the commission rate here. So instead of this one, you use the temporary. So in this example here, you use this temporary variable, right? The first step, you find out what is discount price. So actually, this one here, that is a discount, right? That is discount here. Now, you have the sale price. What is the sale price? Sale price is original price minus discount price. That is a sale price, right? And later on, you have the sale commission here. You have the sale price times the commission rate. So basically, all of the steps here do the same with this one, right? You do the same. You have to do the same, but when you can use a temporary variable to make it straightforward, one by one, step by step. Because this one also is very simple, but later on, you see, you have many complicated formula. So it should be better you break it down and you use a temporary variable.
Sure.
Yes.
Excuse me, I have a question. Both of this method has the same memory. We use the same memory and time of calculus, please.
Sorry, say again.
The both method will use the same memory and the same times of calculus.
Sorry, I cannot get you. Can you type in the chat? What is your question? So basically, in the debugging exercise that they expect that you have understand about the pseudocode here. Right? And if you go over on the slide I mentioned in the class here, they expect that you have to understand about the structure of the pseudocode and the flowchart when you work the debugging exercise. Okay, so basically when you use the variable name, right? When you use again, I mentioned it on the class already. When you use the variable name, it refers to the one memory slot in the memory, and the memory slot is the name of the variable name. Right? That's all. That's the process here. Okay, so think about if you think about this one here. If you have the length, think about you have the length, you assign number 10. So basically in job program. What is calculation of time? Okay, can you sum it up and can you send it email to me? I really do not get your question here. Okay. Okay, so that I explain the benefit. Sometimes you break it down and you use a temporary variable, right? Many clear do not combine multiple statements in one line of temporary variable. Okay, that's one temporary variable here. Okay, now writing clear prompt and echo input. So what is echo prompt? I explained it already. Right? The prompt is a message displayed on the monitor to ask user for the response. You have prompt for the input also. You also have prompt for the output also, right? And use in both command line and graphical user interface interactive mode here. Now, echo input. What's the echo input? Echo input, the repeating input back to the user, to the user either in the subsequent prompt or in the output here. Now let me explain about the program here. You understand what is the echo input here. Now think about the program here again, right? Think about go back to this program. Okay, that's about that. So this program is you have to enter the width and you have to enter length to find out the error, right? Okay, now if you enter the number width 10, if you enter the number width, if you enter width number 10, And length number 20, you find out area is 200 here, and you print out the area is 200, right? So it's okay, but it should be better. You have to print out that the area of the rectangle with the width of 10 and the length of 20 is 200. It makes more sense, right? Now think about this one. How we work here? So how we work with this one? Right? How we work? You can modify this one here. So now think about this one. I put it here. It's the area of the rectangle. Sorry. With the width. Of what? What do you think? Of what? I take it out value stored in the x variable, right? And he stored in the x here, right? And the length of what? Y. Is. Okay, so see what happened with this program. Okay, so see what happened with that program here, right? So it depends on your input. It depends on the input, right? So if you enter the number x here, if you enter the number x at the beginning, you enter the number x 10 here, and you enter the number y 20. If you go enter 200 here, and print out the area of the rectangle with the width of 10 and the length of 20 is 200 here, right? And later on, if you enter the number 15 and 25, you take it out the number here. Right? So it makes more sense for the end user. Right? It makes more sense. If you use an equal input, that means you use a value, you got it from input and it bring it to some part of the output here. Right? So see, when I run this program here, I run this program again, right? I run it here. And the number 10, number 20. Oh, sorry, I have to correct it here. This one, delete this one. Now I run it here. Number which I stored number 10. You see, I stored the number 10 in the variable x here, right? Number 20, I stored in the variable y here. So that's why I take it out. I add a rectangle with a width of 10. And here actually you take it out from x value, right? You see, take it out from x value, right? And y here 20, you take it out the number, right? So that's why in the output I have output here. I have area of rectangle with a width of 10 and the length of 20 is 200. Right? And later on, if I run it, I have a 15 here and 25 here. Okay, it changes here. Right? It makes it a little bit sense for the end user here. Any question? Let me know. Any question?
For creating the modules in Raptor, is
Yes.
it just can you go over that again, how you initiate that?
Okay. So think about let me for any program work here, right? Think about any program work here. Okay, that is the program, right? That's the program here. You see, you have the you have input, you have the processing, you have output here. Right? So think about this one. To break it down into the modular structure, the first step you have work with the core here. The core in the router is where you call the module or function here, right? So here, right? So in that case, you have to put the name for the module, right? You can put the name here. You can put the name here. It's an input. Okay, whatever it is, get like that. Okay. So That the process you create the submodule in the router, right? So see, when you work with the graph data, that means you want to get width and length, right? So basically for this one here, you do not need from here. You have to get it in this one. Right? I just copy it and paste it and copy from the main and paste it in here. Make sense? Hello?
Yes, thank you.
Okay, so now you do the same. You can do it processing here. You do the processing. Okay, so the same, and in the main module, I copy this one in the processing. I paste it in the processing. Where? Okay, and the last one I can think about this is output data here. Okay, that is the way I modify this, but actually in the long program, you have to create the module first and coding under the module, right? Not by the copy and cut here. But anyway, that is the way you work with the submodule in the router here. Any other question? Hello?
No questions.
Here's the same, right? You always writing a clear prompt and equal input here. So think about this one. Right? You have process program, you have declaration, string name and number, balance, input name and balance here. It's not root program, right? You have no problem here. You have no problem here. Instead of that here, you have to use the prompt here, right? You see, this one, you have no problem, right? And basically, if you are thinking about, if you are the end user, you have no idea what's going on. Right? You can do the same here. You can do the same. You can think about when you work with the when you work with think about you have the I equal to input. Next. Okay, this program work, right? I run it here. Okay, see, I have no idea, right? I have no idea what's going on with the program. You see, you have no problem here. Of course, I am the one who writes this program. I know that I have to enter the number here. But if you think about you as the end user, you have no idea what's going on, right? So that's why for every program, I always try to include the meaningful prompt in the input and in the output also. I think about this one. Right? So instead of doing this, I have to put here and the length. I have to put here and this is here. Okay, now I run it again. And so we know what is going on here, right? And the error here, 200 not really makes sense much, right? So I can put it here. See, a little bit of my cost. Okay, that is a process. That is the idea that you always have to writing a clear prompt and equal input also. Equal input that I mentioned already, right? You include the you bring the value of the input into the some part of the output here. So you see, that is the way you work with the flowchart and pseudocode. But you see, for this one, you have no problem, right? For this one, you have no problem. But it should be way better if you from here. You tell that please enter customer name. That is the problem, and you store it in the variable name. That is the problem, and you store it in the balance name. Right? The same. So instead of input name only, you have the problem here. Please enter customer name, store it in the variable name, and please enter balance to store it in the balance variable. Right? Okay, and here that is equal input here, right? In the output here, you take the name from the input. That's the problem. That's equal input here. Okay. Now every program you write, it should be better you plan before you code. So far, all the program very simple. You do not apply it. But again, try to put with good habit that before you work with any program, try to plan it here. So what is the plan? Plan, you have to find out what is the expected output, what is the input here, and what's the formula you need to do, and what's the algorithm you need to do in order to deliver the expected output here. And also, if you have a complicated program, to maintain the habit of draw the flowchart, how they are related together, right? Or writing pseudocode, and have the dash check programming logic of paper. It's very important. See, basically for every program, you have the list all of the testing scenario, right? What happened if you enter the negative number? What happened if he enters the string number here, right? Everything can be go wrong with the program. That's why you have to list out all of the testing scenario. And you later on, when you're done with the program, you come back and you follow the dash check here. You test it by test number 1, test number 2, and so on to make sure it works perfectly. Think carefully about variable and the module name. Use design your program statement to be easy to read and use here. So that's all about the slide and for this class for today's class. So summary, you have the content, the literal and variable and name constant. The arithmetic, you have to follow the rule of the priority, right? And you can break down program into the module, and you have learned about the hierarchy chart. You know what is the relation between the module here. And as program more complicated, you need to have a good planning and design here. Now, so I think that's the Python. Okay, we have the Python. In the Python here. The Python overview. So I mentioned in the class, right? So in the Python overview for the module 2 here, I need to mention about the variable, about variable reuse, and okay, and also concatenate string and the number. Yeah. Now, think about in the Python if you work in the Python, variable always follow the same. Variable, that means it is changeable. It's a vary, right? And okay, it always have the slot with the name reference to the one slot in the memory here. It's a variable that represents a storage location. Use assignment statement to create a variable and mark it reference to the basic data, and they are reusable. And now, if you want to concatenate string and the number, remember in the Python, you have to convert it into the string in order to concatenate string and the number. If you want to add them together, you see this one is in the string format, right? But this one is a number format. And if you do not convert in string, you got a syntax error. Right? That's why if you want to concatenate them together, you have to convert into string here. So I think this one, as also for on Thursday, we go with the universal markup language and case diagram. I think that's all. Okay. So again, on Thursday, I go on over about the universal markup language, and I will help you again with some of the part of the homework with the pseudocode, with the Raptor and Python. So, do you have any question? No? No question. Okay. Now, let me check the attendance here. John, are you here? Okay. Right here. Jalen, are you here? Jalen, are you here?
Here.
Sorry?
I'm here.
Who are you?
Jalen.
Okay. Content, are you here? Eric, are you here?
Here.
Joe, are you here? Devin, are you here? Evan, are you here? Lindsay, are you here?
Here.
Michael, are you here?
Here.
Devin here. Okay. Matthew, are you here? Okay. Mallory, are you here? William, are you here? Hunter, are you here?
Yeah.
Okay. Cyrus, are you here? Okay. Max, are you here? Marcus, are you here?
Yes.
John, again, he's not yet there. Paul, are you here? Here. Who are you? Yeah, you. Okay. Ade, are you here? Adolphe, are you here? Okay. Daniel, are you here?
I'm here.
Parker, are you here? Carl, are you here? Carl, are you here? Otis, are you here?
I'm here. This is Carl.
Who are you? Who are you?
Carl,
Okay. Otis, are you here? Alex, are you here?
Here.
Alex? Drew, are you here? Here. Okay. Tucker, are you here?
I'm here.
Luke, are you here? Here. Okay. Malcolm, are you here?
Here.
Okay, so I see you guys on Thursday. Okay. Here's my suggestion. You go over slide again, right? And you see about the assignment. I see what is going on with the router, what's going on with the pseudocode and the Python. And you can write any question to me on Thursday. And that's, I think it's way better. At least you have some preparation before you work with the homework. Okay.
I do have one question regarding the executing Python assignment.
Yes.
I did complete it and it gave me 100%, but I didn't hit the confirm button. So it gave me a 0. I didn't realize it. So I went through today and hit the confirm and it accepted it. I don't know.
And that's the thing. If you are on the class last week, I mentioned it already, right? And also I mentioned it in the announcement already, but I don't know how can I skip it. But anyway, you can go back and submit it. It's okay for me.
Yeah, I didn't know about the confirm button. Sorry. The Cengage, it acts up on me for some reason, but
That's okay. 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 I'll see you
All
guys.
right. Well, thank you very much.